Hello everybody. In this video I will discuss with you the drug I chose, which is methamphetamine. I chose methamphetamine for two reasons. One is because I recently finished watching the show Breaking Bad, which is about a chemistry teacher diagnosed with cancer, and to pay for his treatment he begins to cook and sell methamphetamine. Another reason is that it's a drug with high prevalence and usage in Kern County, so I wanted to understand it better, how it affects the user, how it interacts with their body chemistry, and what causes it to be so dangerous. Now on to information about meth. Methamphetamine has a melting point of 170 degrees Celsius. Methamphetamine also has many names, from its IUPAC name being N-methyl 1-phenylpropane 2-amine. Meth also has more commonly heard street names such as crystal meth, ice, speed, crank. Its medical names, its trade names in a medical sense are called desoxin and methadone. The structure of methamphetamine here looks quite similar to a chemical you'd see in class. Just going over it, on the left side we have a benzene ring, on the right side we have an amine, which also has a methyl attached, and then on the bottom we have a methyl, which is quite important how the chemical behaves. And right here in the middle, we have a stereo center, with the left side going towards a benzene ring, the right side going towards an amine, the bottom going towards a methyl, and the top going towards a hydrogen. An important feature to point out from the chemical is that the stereo center causes the chemical to be chiral, meaning that it has two enantiomers, and that depends on whether this methyl points towards you is R or points away from us is L. If it's L, then it's levoamphetamine, which is a over-the-counter nasal congestant. And if it's R, then it's methamphetamine, which is a Schedule II class drug. The difference in effect is because the methyl, if it's L, is surrounded by the rest of the chemical, and if it's R, is easily accessible. And while I'm going over similar in structure but different effects, another is Adderall. Adderall, or amphetamine, is an over-the-counter stimulant that is used to treat ADHD. What sets meth and Adderall apart structurally is that Adderall has a hydrogen bond attached to the amine instead of a methyl group. Both Adderall and meth actually have similar effects, as both are stimulants that can be used to treat ADHD, decrease hunger, and increase energy. The drastic difference in effect in meth has to do with how methyl enhances the strength of meth and allows for the brain to release much more dopamine into the brain. What basically happens is that meth will interact with the interceptors in the brain that control the amount of dopamine that can release in production, so dopamine overall increases. The reason I mention this is because when I show the 3D structure, I will be using Adderall instead of meth. For the most part, while methamphetamine can be used medically, it's mostly used as a recreational drug. Meth will interact with the brain and release high amounts of dopamine, which is the chemical that gives pleasure reward, as you can see on the image. This is what causes it to be highly addictive. It will give a quick and short high, but after a while, the user will crash. This crash is where the term tweaking comes from. Other effects are increase in energy, decrease in appetite, faster breathing, rapid heartbeat, increase in blood pressure, and body temperature. I won't be going over the long-term negative effects as that is beyond the goal of this paper. Methamphetamine is a molecule that can be created synthetically. There are a few different ways to produce meth depending on what reactants and processes are used. I will show two different processes to create meth. The popular method for meth on the streets uses cough medicine, pseudoephedrine, which is an easier method as it is made in homemade labs throughout. The second method is a reductive amination reduction reaction, which most chemists will follow to synthesize. As we can see here, we have two different syntheses. I'll start with the top one first. On the top, the reaction begins by using phenylacetone first. It is reacted with methylamine and formic acid to form this next compound. It adds the methylamine right here and the formic acid onto the amine. Next, you will react it with more formic acid and it will add onto this double bond next to the amine. The next, the oxygen will remove itself and add CO2 onto the side. And last, for the last reaction, we'll react it with an acid such as H3O plus or even HCl, and we'll remove this compound on the right side, leaving you with the racemic mixture of RNS methamphetamine. On the bottom, we can see we have S-pseudoephedrine synthesis. To start, this is the method that will be used in most illegal operations. To start, they'll get cold medicine and extract the pseudoephedrine from the cold medicine. Next, they'll react it with hydroiodic acid, and the hydroiodic acid, the H will react with the OH, making it into a water, turning it into a leaving group. Next, the iodine will come in and react, forming an I leaving group. Next, it'll react with HI to pull the iodine off of that, and you'll react it with red phosphorus. After that, you'll be left with an R methamphetamine. Here are the references I used for my paper. The two highlighted ones are the ones that I used to help me create the synthesis for methamphetamine. Now we'll be looking back on how methamphetamine interacts with the brain. In the ventral striatum, in the nerve areas where dopamine is produced and interacts throughout your body, in a normal state, your body won't have too much dopamine flying, passing around in between the nerves in that sense. But once methamphetamine is introduced, methamphetamine will interact with the receptors, it'll interact with the transporters, and it'll start flooding your brain with dopamine, giving you that euphoria high feeling. For the structure, we'll be looking at 4LAR, which isn't exactly methamphetamine, but instead amphetamine, which is a very similar compound. It's just a weaker former of methamphetamine. What happens in this compound is that it sequesters away amphetamine away from the brain and pretty much takes away the effect it has on you, taking away the dopamine high. And here we can see the long strain compound 4LAR interacting with amphetamine. And as you can see right here, here is the compound. All right, now we're on the Chimera app and we're looking at amphetamine and how it interacts in the 4LAR. There isn't too much going on in this compound, although there are a few reactions. This nitrogen interacts with the plane of this 5-ring compound on the back. There's an interaction between the nitrogen and this 6-ring over here. And then there's another interaction between this oxygen and this nitrogen. Thank you for watching and have a nice day.